Section 9.3 deals with arcs and angles. The big ideas here will make conjectures about inscribed angles and talk about the relationships among the angles in a cyclic quadrilateral. Set this into your table of contents, and then we'll work through a few of the conjectures together. Our first conjecture is the inscribed angle conjecture. If an angle is inscribed, then the angle is half of the intercepted arc. Let me show you what I mean. Let's draw a circle and an inscribed angle, and let's say that the inscribed angle is 50 degrees. The intercepted arc is twice as big. Right? The angle is half of the arc. Next, the inscribed angles intercepting arcs conjecture. It says if two inscribed angles intercept congruent arcs, then those angles are congruent. What does that mean? There are two different possibilities here. If, in the drawing from earlier, we had another inscribed angle that intercepts the same arc, then those two angles are congruent. They're both 50 degrees because they intercept the same size arc. Likewise, if I have congruent intercepted arcs, the angles that produce them have to be congruent. An example for you, we've got a central angle and an inscribed angle. Let's say the central angle is 40 degrees. How big is the inscribed angle? Well, if the central angle is 40, then so too is the intercepted arc. Right? Central angles just equal the arcs. And so the inscribed angle is half as big, 20 degrees. Here's another example. Take a minute, sketch it. We have 36 degrees, ABCD, and 4x. Well, I know that both of those angles will be 36 and 36. And so that means 4x has to be twice as big. 72, so therefore x is 18. Next conjecture, the angles inscribed in a semicircle conjecture. It says if an angle, or if an inscribed angle intercepts a semicircle, then that angle is a right angle. So let's take a look. The inscribed angle here intercepts 180 degrees. Therefore, the angle opposite it has to be half as big, 90 degrees. And then our final conjecture for this set, the cyclic quadrilateral. So if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So let's draw an inscribed quadrilateral. I happen to call mine L, M, and P. And if you look at angle L, it intercepts arc M and P. For sake of argument, let's say it's 200 degrees. I know that the angle L is half as big, 100 degrees. Now look at the angle opposite it. Angle N intercepts arc PLM. Well, arc PLM is the rest. In other words, it's the rest of the circle. Circles make up 360. 200 is on the red side, so 160 is on the blue side. And so that means that the angle opposite 100 has to be 80, because 80 is half as big as 160. So angle L and N are are supplementary, and likewise P and M are supplementary. Let's work an example together. Here I've got circle P. Draw a diameter, UT, and then we'll draw V and S such that arc VU is equal to arc SU. Then let's say that angle STU is x plus 9. 2x plus 6 is angle TUS. Solve for x. Well, we're given that the chords are congruent. If the chords are congruent, then the angles that the inscribed angles that intercept them have to be congruent. So x plus 9 and x plus 9. Then note the fact that we have a diameter means that angle S must be a 90-degree angle, because any inscribed angle that intercepts a semicircle is 90 degrees. And so that likewise, if that's 90, so too is this 90. So then if we look at just triangle TUS, we know that the three angles add up to 180. And so therefore, solving for x, we'll get that x is 25. If you take 25 and sub it into all of the angles, we'll find 34, 56, and there we go. Lastly, take a look at this inscribed quadrilateral, cyclic quadrilateral. If ABCD is inscribed, remember that opposite angles are supplementary. So that means 4x plus 6x plus 10 is equal to 180. And likewise, the green angles, 3y plus 2 plus 6y minus 2 is equal to 180. And then we get y is 20. I have an example for you to try. Sketch this into your notes, push pause if you need some more time, and solve for w, x, y, and z. This is what we'll start off with in class.